first question is this. How do you know a problem is simultaneous equation problem? Two things. There's a word for it. Two equations, one. No. Two equations and two variables. That's what I mean by not two things. George. Where is it? Okay, so two equations. Now, how do you know the simultaneous equation is one linear, one quadratic form?
One has power,
Both of them have power.
Wait, no, one has square.
Is everybody paying attention to these very, very important questions? Because without knowing which form it is, you might end up using the wrong method. And you might just get stuck. Okay? So the question again, how do you know it is one linear, one quadratic form?
One has square, one does not have square.
There's a square and there's no square, basically. So the previous one, they are just linear problems. So something like 3x minus 2y maybe is equal to 1, x plus y is equal to 2. These are two linear equations. What does linear mean? To the power of 1. Everything is to power. Each term is power 1. My question is this. X plus 2y is equal to 2. Xy is equal to 1. Is this under the category of two linear equations or one linear, one quadratic? But I can see power 2 in there.
Because the two variables
Yeah,
combined,
that's it. This is what it's saying. Each term. So if I have this, in this term you have power 1, in this term you have power 1. Linear. Every term is power 1. In this term power 1, in this term power 1, linear. But check this out. This term power 1, this term power 1, linear. Let's say this is 0, right? This term power 0, not because of this 0. So this is like 0x to power 0. That's what I mean. Okay? But this term, there's power 1 and power 1. The combination of the power is what? 2. So this is quadratic. So this is one linear, one quadratic. Does that make sense? So some of this might be a bit like tricky and kind of confusing. Don't get confused. Whenever any term has a combined power more than 1, it is no longer linear. Could be quadratic, could be cubic. Okay? Now, today we'll talk about one linear, one quadratic, like I said. Let's pick one of the problems from yesterday. Our next question will be, which I think somebody answered already yesterday. Can you use elimination to solve one linear, one quadratic? And you're going to end up having two problems in the quadratic, two variables in the quadratic format. Look at this. I wrote something like this yesterday. X squared, y squared, 25. Do you remember this?
Yeah.
Xy is equal to 7, for example. Let's pretend we want to solve by elimination. What do you multiply this with to cancel? Times x. It's not just the number. When you're solving math problems in maybe from 5, from 6, you realize you're not just multiplying by a number to eliminate. You're multiplying by anything that will make them look the same.
Also, you can do times y.
You could do times y. Good. Alright? If I do times y, for example, I'm going to end up having x squared, y squared. Do you agree with me? Then what does the other one become? xy, y squared, 7y. What do we do now? Done? You agree? What is this?
X squared minus xy
Is equal to? Does this solve anything? No. Because you're having one equation in two variables, so you are stuck. The same thing will happen if you use x to multiply, just trying to eliminate x part. This is why you don't use elimination method for one linear, one quadratic. And that is why we learn substitution method. Do you understand from the question you asked yesterday? Oh, why do we have to? Because do you guys remember that part of the class?
Yeah.
You know, why do we have to learn it? But seriously, that's a good question. Why do we have to learn something long and maybe a bit difficult if elimination could just do it easily? This is the reason. All these are just basic skills. They come in handy when you least expect them. Okay? So let's take first question from yesterday as an example that we do together. How many people tried it and you got one of the answers? Okay, you got one of the answers? Okay, good. So give me one of the problems from yesterday.
2x plus y
2x
plus y
plus y
equals to 9.
equals to 9.
X minus
I need everybody's attention, please. Yes?
x minus 2y is equal to 7.
That's not one line.
It's not one linear, one quadratic.
Oh, you want one linear, one quadratic?
Come on,
Oh,
Jamila!
alright.
Seriously?
Miss Daniel.
So then
Yeah,
x,
there's
y,
a question there.
Who was the question?
That question. That's question 6.
x,
I don't want to begin with something like this one. Maybe if you want me to.
Okay, 5.
Do we start with this one?
No, let's start with 5. Let's start with 5. And then stay here and then 7.
Does 5 have 2 squares?
No.
Just one square?
Yeah.
Okay, we'll start with that and I do this next. How about that?
X,
Okay.
y is equal to 2.
X, y equals to 2.
Y is equal to x plus 1.
What?
Y is equal to x plus 1.
Y equals to x plus 1 like this.
Yeah.
Okay, so these are 2 equations. Is this linear or quadratic?
Quadratic.
What about this one? So that's why we have one linear, one quadratic. Again, one linear, one quadratic doesn't mean the first one is linear, the second is quadratic. It doesn't matter which one comes first. Okay? Alright, so this is what you do. So I'm going to just label them so that when I mention equation 1, equation 2, you know what I'm talking about. Yeah? So, in substitution method, what is our goal? What's the first thing we do?
You have to get one thing as a subject of
The formula, which has been done for us. Can you see that clearly? So subject of the formula is done, that part is done, right? Which is this one.
Yeah.
So when we get something as subject of the formula, what do we do
You
then?
have to substitute it.
Substitute into the other one. So basically we put what equation into what equation here?
Put the second one in.
To the first one. Does that make sense? Please, I need everybody to be part of this. I can't hear this. I want you to talk. Are you making some music? George, I am man. Put second equation into the first equation. Can everybody see that? I'm trying to manage the space as I'm starting here. So when you put this here, what do you get? Instead of xy, it will be what?
X bracket
X plus 1 is equal to 2. So what do we do now?
X squared plus x.
X squared plus x is equal to 2. What do we do now?
You have to factorize.
Factorize. Factorize is this step. Are you saying I go back here?
No, like you have to make the y like.
You make the what? You make the right side 0. Why are we making the right side 0?
Because you need to factorize. So
No.
if you make it like.
Because you have to make it a quadratic
Then you can
equation,
factorize.
then you can factorize.
Okay.
Alright. So x squared plus x minus 2 equals 0. Does that make sense?
Yeah.
Does everybody remember how to factorize this?
Yeah.
So what do we get when we factorize?
X plus 2 bracket x plus 2.
X plus 2?
And then x minus.
X minus 1. Does everybody agree with that?
Yeah.
Is that what we all got? Okay, good. So at this point, what do we do?
You have to do 2 different answers for x.
I'm asking you, what do we do?
Oh.
I know I have to get 2 different
You do
answers.
x plus 2 is equal to 0.
So x plus 2 is equal to 0, or
X minus 1.
do we still remember why this line? Can somebody remind me why?
One of the bracket is 0.
Why?
Because it equals 0.
Because
Every time 0 is 0.
because the product is 0. If the product of 2 numbers is 0, one of them will, at least one of them will be 0. Okay? Some of you are not paying attention, I have that feeling. And whatever you guys are talking about, you need to stop it. If you can't stop talking beside that, please change your seat. So from here, x is equal to -2 and x is equal to 1. So in most one linear, one quadratic problem, you're going to get 2x and you're going to get 2y. 4 answers. Does it make sense? To avoid any confusion, I'm going to change this to red so that when I use it, you know this is the red part and this is the blue part. Okay? So now I got my x. What do you advise I do next?
You substitute your 2 answers into the second equation.
Why second equation?
Because you started y as a subject.
Y is already a subject, so life is easy. Yeah, basically. So, I put x into the second equation. So I'm just managing this space. Can everybody see it? I'm trying not to use all the space here. Rita, can you see the board? Okay, good. So y equals x plus 1. So for this part, what's that? Y equals negative 2 plus 1, right? So y equals negative 1. For this part, what is that? Y equals 1 plus 1, y equals 2. Now, because there are 4 answers, to be more organized, you put them out separately. So this is what I mean by that. So for this one, I can say x is equal to minus 2, y is equal to what? Everybody? Negative 1. And the other one is what? X is equal to 1, y is equal to 2. You bring them out like this.
Wait, and
It doesn't matter. Does it matter?
and is both.
Yeah.
And this book. Oh yeah, so you see that of them. Good. Now another thing, if you read some, because I know some of you probably do some practice, you want to check the past question, marking scheme, you may not see this in this form. It may be like this. Can you see that?
No.
Do you know why?
Because X is on the graph.
In the graph, x is the first one, y is the second one. So if you don't put it like this, you can put it like this. Oh, the solutions are this and this, we understand. It means both of them satisfied. Okay, yes sir.
But isn't this already 4 graphs?
No. This will be 2 graphs. Remember, this is 1 graph, this is 1 graph. Then they meet in 2 places. So if we get to the graphical part, we will end up getting something like this. So this is the first answer, this is the second answer. One would be a curve, one would be a straight line. Then they meet in 2 places. Yeah, this is going to be a curve. Remember, it's quadratic. Actually, it's an inverse graph if we get to that point. Because y will be 2 by x, right? An inverse graph would be a curve, but maybe not a parabola curve. Something like, it would be like this, something like this.
Oh.
So that when you draw your straight line, oh, this will meet in 3 places. Definitely 2 places. The only situation where you have 3 places is when you have cubic equations that looks like this.
Ooh. Oh, I've seen those.
Yeah. Maybe in your physics class?
No.
No? Anyways, we don't want to get too... So does this make sense, everyone?
Yeah.
Now let's try this, but you have to tell me how to do it. With this approach, we're going to do this now, together. Are we ready?
Okay.
So question 2, can I ask everybody to please pay attention? Question 2, x plus y equals 7, x squared plus y squared equals 25. Yes?
So you need to make X or Y something to the first one. X equals
7 minus y. This will be the third equation, right?
Yeah.
Just for, just to label it. I like labeling it.
Now substitute that in second.
So we put 3 where?
Into 2.
Into 2. Do we all agree?
Yes.
Okay. Put 3 into 2. Irene, don't erase now. Let's do this together. So when you put it, what do we get?
7 minus Y.
7 minus y brackets.
Plus Y squared equals 25.
What do we do now?
Then you expand the brackets. 49
49.
minus 14Y.
Are you sure not y squared?
No.
This is 7 squared.
Minus
This is-
14Y minus. You have to do two brackets.
Who will agree with me? This is the result. I can't be wrong.
What?
I'm supposed to be the teacher, right?
Oh, is that one? No, it's 14.
There's a 14 one. Why is there a 14 one?
Because 7 times 7 is 49.
Remember, it's 2 brackets. Remember this?
Yes.
It's 2 brackets. Okay? You know the smiley face, according to Trudy.
Yeah.
Yeah. No, she claimed this is smiley face.
Who doesn't know a smiley face? That's an alien face.
Well, so this is 49, 7y, 7y, y squared. And this is 20 already? Okay. So, I'm sure we can finish. Okay, so what this is why there is a 14, followed by what? Plus y squared, followed by? Plus y squared is equal to? Yanko, please pay attention. Don't write yet. Everybody, please. So what do you get? 49. Instead of y don't we group them? 2y squared.
Minus 14y.
Minus 25. Do you know why we have to do this? Why?
Because you're making a quadratic.
Equation. It has to be in the form of quadratic equation. And a quadratic equation is something square without the square, without the variable equals to 0. That format. Yeah? So 2y squared minus 14y, what is this? Plus 24. Agree? What do I do next? Why is it advisable to divide by 2? Makes life easier. Do you understand? Divide by 2 makes life easier. If you do this, you have to do your scissors method and start guessing and guessing. But if you divide by 2, you get something like this, which is easier to factorize. Okay? So divide by 2. You're dividing by 2 so as to make this one 1. Yeah? So we divide by 2. Okay? So when you divide by 2, you have y squared minus 7y plus 12. What are the factors?
Of 12?
Yeah, factors of 12 I give 7, 3 and 4. So what do we have in the first bracket?
Y minus 3.
Y minus 3, y minus 4. Does that make sense?
Yes.
Everybody understand?
Yes.
Good. So either y minus 3 is 0 or y minus 4 is 0, y is equal to 3 or y is equal to 4. Is this the end of the problem?
No.
We need to get x. Okay, so we put y into the third equation, right? So what is our third equation? The third equation looks like this, x equals 7 minus y. So let's put y now, the first one. So I'm just going to write it this way. When y is equal to 3, what happens here? X will be 7 minus 3. Because just work it out like that, okay? Which is 4. Okay? Then when y is equal to 4, x is what? 7 minus 4, which is 3. So the two solutions are what?
4, 3.
So the solutions are, yes, the first one,
4, 3.
4, 3, and 3, 4.
It's or. Wait, no, it's an and.
They are the solutions. It's and actually. This is what, when we say the solution, where does these two graphs meet? They meet here and here. That's what it means. So it shouldn't have been for anyway. But you can say, oh, the solution that satisfies this problem is either this or this. Like, even both of them, I think you should be happy. Don't mess up my English, alright? I've been learning English, learning English in school for decades. Don't spoil my English. Sorry.
I've been learning in school English for 1 decade.
Alright, does this make sense, everyone? So this is all about one linear, one quadratic. Any other question I wrote yesterday, you should be able to try them now even if you are confused yesterday. Alright, let's get to work now.
So, Mr. Daniel, why did you say this was fun?
This is fun, isn't it? Yeah. Oh, you could stop by itself when it is 20.
Sure.
20, yeah?
There's one.
Yeah.
Are you going to send these to Jessica?
Yeah. Now, I'm creating I brought my laptop today because I have to extract with my laptop. So when I create it today, all of you will get the link today. Yeah, that's what I'm going to do. Last year we did the same. So we have like, particularly topics that might be topic we want to watch again and revise, so we'll be doing that more often. If you've solved, so quickly please take this down. Take this down for your own revision later. Of course, I'll take a picture, post on the model if you want to write it later. Otherwise, I'll write another question which you. Come on.
Oh my God. Push it.
All right. Practice questions.
That's always my book.
Yeah, it's always your book. The troublemaker is always your book.
Why? I'm saying that first, and then now you can get Alex's book. Like he's